right, good morning, everyone. This is Kenny with Neometrics Tech. I see people are starting to filter in here, so we'll give it just a couple of minutes, and then we'll go ahead and kick the webinar off. Okay. All right, good morning, Zachary. Again, anybody else who just joined in, this is Kenny with Neometrics Tech. We're going to give everybody just, let's see, it's 10:01. We'll give them, say, 2 more minutes. Make sure everybody that wants to log in has a chance to log in and download the software if they need to, and then we'll get going. While we're sitting here for a second, everybody want to give me a quick shout and make sure you can hear me? Let me know if you got any problems with the sound or anything like that. I think we should be good to go. All right, great. Sounds like we're good. All right, thank you guys. Thank you for letting me know I'm coming through pretty clear. So it's 10:02, so we'll go ahead and kick this off. I think we've got a good amount of people in here, and we should be ready to roll this morning. So again, for anybody new jumping in, my name is Kenny Hart. I'm with Neometrics Technologies. I'm our sales engineer. I'll go ahead and start up get this guy going here. So today we're going to go over one of our products that we carry and we actually use here in-house, Geomagic Control X, and specifically the new Essentials package. So Control X is our inspection program. So if you're a quality control manager or someone in that sort of a quality engineer, somebody in that sort of some sort of role with your company, this is a software that'll allow you to take 3D scan data of any part that you need and import that and overlay it on an existing CAD file and check for any inconsistencies between your CAD model and your manufactured part. So there's a whole bunch of tools. We'll go into a few, and we're actually going to do 2 live setups in this webinar here. But Essentials is the new version of the software or a new offering. The inspection software is a little pricey, and Essentials gets most every tool that anybody is going to use into a much more affordable package. So it definitely decreases that barrier to entry and something that everybody can put into their workflow. And again, it's got pretty much everything that you're going to use within an inspection program for for a large majority of users. So I'm going to go ahead and hide this slide. There's my contact info. I'll pull it back up later, but if you got any questions after this webinar, you can get a hold of me, Kenny at neometricstech.com, or my phone number is 407-687-6202. And let's go ahead and get started here. So I'm going to pull up my first work through here. So this is a Control X workspace. So we've got, if you're familiar with a CAD program, this is very, very similar. I really like how they this whole setup works. So we've got our main toolbar up here with our different tabs, and within those tabs, so if I go to dimensions, all the dimensions, GD&T, things like that are underneath that tab. We got our alignments tab, a few different things here. So let's go back. I like to stay a lot of times in the main home tab. It actually has most of the tools that we're gonna run here. Over on the left side, we've got a tree view, very similar to a CAD program. Down at the bottom here is going to be our table of values, so all of our dimensions. And of course, in our field of view, you can see there's our CAD file. And I've already preset this up. So this is how the software is really going to work in a live run. So I'm going to show you how you would utilize it on the shop floor or in a general inspection environment. And then we'll go through a little example of setting up your own inspection. But this is what makes this software great, is the time goes into scanning the part. And then once you scan the part and you already have this selected, you can just import the data. You'll see here in a little bit, and it'll pull all these dimensions. So that's what we're going to do. So I'm actually going to flip from our Control X software over to my Creaform VX Elements. That's our scanning software for our Creaform systems. I want to do just a quick live scan of a sample part, this part here. As you notice before we flip, we've got a bunch of dimensions, and those are the real dimensions of the CAD file, and they're all this light blue color. What that's showing is that they're all, none of them are we don't have any measured dimensions yet. Those are all the nominal dimensions of the CAD file. So what's nice with this software is you can have somebody preset this up, maybe even somebody that's very familiar with the software preset it up, and then we can have an operator who may not need to know the functionality of the software, but is trained in the use of the scanner and can simply import the scan data here. So we'll get more into that here in a little bit. But again, I'm going to swap over to my VX Element software. So that's this right here. And we're going to shoot this part. And when I start this up, I'm also going to, let me turn on my webcam here. So let's do my video. All right. And let's hide that. All right, so I'm going to come on over here. Got the scan already set up and ready to go. All right, I've got my timing cover right here. All right, and this is our HandySCAN 700. So this is our main staple, HandySCAN Black Elite. Previous version was 700. This is our main staple scanner used. You can use it in any shop floor environment. Accurate to 25 microns and takes 1.3 million measurements per second. So you'll see here, even on a very high resolution, I'm going to triangulate this part very quickly. So we can grab any little dimension on this part. So I use this one probably more than any other scanner we have. We have the big brother, the Metroscan, for very large parts, and that works great with Control X as well. So we can scan, we can use the scan data from that. We've got a probe, but for Control X Essentials, we're going to be using it. We're going to pair it with a scanner, just a scanner, because we're going to use imported scan data with that software. So you can see here is very quickly on a part that's, it's a foot, about a foot wide, but it's got a whole lot of geometry that would be a really time-consuming effort to measure by hand or measure with something like a CMM. Here we can get all that surface data extremely quickly. So I do want to make sure I've got pretty much everything covered, but I do have these holes here in actually some dimensions on them. So I want to make sure I get them. I'm going to my single line mode. So what this mode does is it basically narrows down the field of view that the scanner needs to see the coverage of the lasers. It lets me get a little deeper into holes and things like that. So I'm looking at my computer screen here to make sure I got everything. All right, there we go. I think we've got all that data pulled. Got enough data down in those holes to get some measurements. All right, one more bit here. And I'm gonna shoot it from this side. Make sure I get at least three of those, three sides of the intervals of those holes. Everything else, I think I've got that side. All right, let's take a look. Yep, we are good to go. So I'm gonna pause this. So everything is done from the scanner itself. I can pause it. All right, I can go right in what we call finalize the scanner, or finalize the scan. So that actually takes the raw scan data that you're seeing and converts it to a mesh. And that's it. That's all I need to do for taking data on this part. So I'm going to set the scanner right down here. No need to see me anymore. So I'm going to go ahead and turn my video off. Okay. There we go. Turn off the video. Hide that guy there. Okay, so on this too, if you need to, I know I don't have any measurements on this part here, and very quickly I can delete some of this trash. I don't really need to necessarily, but I can get rid of any sort of floating data in that software or in this software's field of view, and just be left with that one scan. Now, if I need to, I can go back in and add more data just by going right back into scan mode. We don't need to do that here. I know I've got the data that I need. So we're going to go right ahead and export this. So we're going to say export mesh. I'm just going to put it right on my desktop as scan 1. Okay, we're going to hide that, and we're going to come right over here to Geomagic Control X. So now we're back to our inspection software. So we've taken the scan data. Let's say we need to take 10 of those. Maybe we're scanning 10 of those in a day. We can go ahead and scan all those, export them, put them in a file, and then we can come over here to our inspection software and start running the data. So all I need to do is come up here. I've already pre-made this part, pre-made the inspection. So I can come up here, go to my desktop, and import scan 1. So what we're going to see is the scan data should import. Now this is pretty typical. There's my mesh. It's never going to be aligned to my coordinate system or my CAD file initially, but over here my tree will kind of go through it, but I've got an alignment already set up. So as soon as I click the generate button here to generate my report, or generate my my inspection, I should say, what it's going to do is it's going to run through my tree and apply everything that I have pre-set up on the CAD file and extract the measured dimensions off of this scan data. And there we go. So it's gone through its alignment, it's finishing up here, and there we have it. So this inspection's done. Before I go to the report, I do want to kind of run through a few things, but all you have to do here is export your report. So that part is completely measured, anything that you need to take off of it. That's what the beauty of this software is. To get a real quick rundown of some of the things I have here, I'm going to hide my mesh. You can see obviously it's aligned to my part, okay? And I've got it as I've got a datum alignment set up. So the initial alignment is kind of like a pre-alignment. I run that. I'll show you a little bit later with any scan data set. And then I have it extract the datum. So if I come down here and I hide my groups, I've chosen a few datums. This plane, this top plane, and the circle at the intersection of this cone and this plane. Those are my datums A, B, and C. All right. As you can see, if I turn my group on, you see my datum B, datum C, and datum A. So now all of my values here have a measured component. All right, so I can come down here, I can select them, okay, and you can see we've got, they don't have a little asterisk next to them or anything, and they're all color coded. I've got this set up to where my my deviation flags here are, big enough to readily see, and they're color coded to my, to my bar there. So I've got a bunch of different dimensions. I've got an angle. If I click on each of these, it'll highlight the faces. So I've got an angle dimension between datum B and datum A. I've got a flatness on datum A. I've got a surface profile down here. Okay, so all kind of different things. Anything that you can, anything you're going to find in a measurement function is going to be in this datum section here. So you could just do linear dimensions, angular dimensions, radial dimensions, all that stuff. So on top of that GD&T, I actually have a cross section as well, which I told you I needed those circles. All right, and it's actually measuring. I've got some of these set up. I've got a circularity. I got a couple of positional tolerances, and I have these diameters. So all that stuff we can go ahead and preset up. And then the other thing I want to show you here is my analysis group. All right, so if I turn my analysis on, I really like this view because it gives a very quick view, very quick overlay of how our parts actually measuring, how our real parts measuring to the CAD. Let me turn off my GD&T and measurements here. There we go. So there's my deviation with a number of deviation flags here. So let me make those where I can kind of move them around. So if you got some areas of interest when you run this, you can apply little single point deviations just to give the viewer a very quick reference of where all that stuff's laid out. So that's all that I've got all in my report. Now I'm going to go down to generate report right here at the end. All right, and here's where I can choose. I've got a Neometrics template, so this is my own personal, or I guess our template that we use here. and just slightly change. You can set up your own custom template as fancy or as as simple as you'd like. And I can over here selected entities. I can choose what I don't want to show. So in this, I'll go through it a little more when we set one up. But initial alignment, that's just kind of like my pre-alignment. I really don't want that to be in the report because it doesn't really matter. The datum alignment is what I want to show. And then I've got a couple of circles that I really don't have anything called out on. They're more for dimensioning too. So I'm going to leave those out. And I can also reorder my report. So if you have a very standard report setup that you need to match, you can do that here. At the end of the day, I'm going to go to generate. And what this is going to do is it's going to take that setup and it's going to spit everything out into a report that I can export out of here as a PDF and log at that point for whoever I need to. Here we go. So here's my report setup. If I scroll through my page, I've got my header and all my information for this report, the CAD file, nominal data, the scan data. You can flip these around too, depending on how you have the CAD file for a particular part. You can edit these views here. All right, so datum alignment. I've got my datums called out, so you see datum A. B's off the page, so I could certainly update that. And then C here, but you can see the deviations for my different datums called out on that as well. Now when I go to my 3D compare, there's my color map with all my deviation flags and my histogram for those deviations. So because I do have a datum alignment based off of this plane, it does seem like the half of the part is kind of thrown off because maybe the plane or the part's kind of angled in reference to that. So that'll reflect in my histogram. I got all my stats for my deviations. Percent out of intolerance and out of tolerance, very helpful values there. All right, along with my 3D comparison points, so listed down here with the deviations. Scroll down a little further. I actually have a 2D cross section, so I didn't show you guys this, but just like I had a 2D cross section that had those circular dimensions we'll show here in a second, I also have a color map as well, where I can pick some points. You can see where the cross section lays in the part. So it's basically a 2D version of this, just a section cut through the part. All right, now we're going to come down a little further. There's my 3D dimensions laid out to where you can see them very nice. If I've got a ton of dimensions and I have like a 2D drawing, I'll actually do multiple groups of dimensions all set up like the views in a 2D drawing or something like that. Make it very easy for the end user to tell what's going on. All that's customizable. And then there's my 2D cross section and where that cross section is taken in the CAD file. So that's it. Yeah, at the end of the day, we go to File. You can save the report out as Excel, PowerPoint, PDF. I generally like PDF, and then you're good to go. So when you go to do your next part, I'm going to close this down. We can say Add Result. So if you've got 10 of these parts, you say Add a Result. It'll make a new table or a new tree. Basically, we get Result Data 2. And then we'll go in and we'll import the next data set, and it'll run exactly what we just did. It'll run the next data set, and then we can generate the report and export that PDF as well. So very quick and easy to get multiple parts done. Multiple parts like this, that would be a very time-consuming CMM process or process of measuring and recording by hand. The scan data just took a minute to capture, and then we can generate a report there. So that's that's kind of how you want to implement the software within your workflow. I wanted to show you that first. I'm going to pop back over. Let me minimize this. I want to pull up my webinar here to make sure that we don't have anybody. I want to make sure there's any questions. Okay. All right. It looks like we're still good. Let's see. I do have a note that says, "Cannot hear you." Can somebody confirm whether or not that's the case? Before I move on, I just want to make sure that you guys are good to go. All right, I think we're good. So if you guys have any questions, all right, looks like we're good. Okay, great. Yeah, and definitely if you guys have any questions for the next example or this past example, just type them in this chat, and I will get to them after I get done with that example here, and we'll move on. So like I said, any questions, let me know. Otherwise, we'll go ahead and get to the setup example. So Again, this is my example. This is how you want to implement it in your, maybe an operator would need to know how to do. Basically import your scan data, and then let it run the report, click the generate button, and then export the report. So yeah, if somebody who just knows how to use a scanner and can press an import button, that works great. So if you're a user that's going to be setting this stuff up, the software is also very user-friendly. So I'm going to minimize this one, and we're going to go to another view here. So this is a blank report, okay? And what I love about this software is it's very, very user-friendly. The learning curve on it's very quick. Again, especially if you're a CAD user, everything's laid out very similar to what your CAD program would be. So I've got my import button here. All right, and first thing I'm going to do is go to import my step file. So I can import IGES and step. And here we are. So I've got another sample, just a sample part, but this one it'll very easily let us see what dimensions we're taking. I do like this part for a simple view screen here. So I've got a few things. I've got some spheres. I've got some cones, a slot, things like that, and a few angles. So what I want to do next, if you don't have your scan data, you can actually set these up ahead of time without scan data. But if you do have one part scanned, it is nice that you can import the scan. So go ahead and pull that in. And the reason I do like to do this is that I can definitely make sure that whatever dimension I'm trying to take works correctly. So if it doesn't, it's very easy to update that feature if something fails whenever you import your first part. But if you do have a scan of your first part, it does work nice to see, and definitely make sure of what you got going on, and that inspection program, that automatic inspection is going to be robust as you import parts down the road. Okay, so we've got our scan data here, and we have our CAD file. Again, I need to get the scan data on top of the CAD file. So we're going to click initial alignment. And if you already have this software, this would be a great kind of workflow for you as well. With scan data, I always do an initial alignment first. And the reason being is it just gives us a quick pre-alignment that we can then perfect in the next stage. So in this one, instead of doing a datum, we can run a datum alignment, and we can click a few datum features. I can just run a best fit. Maybe this part I just want to see in a best fit condition. All right, so the best fit, it may or may not update anything, but it's going to take the initial alignment and really check to make sure locally that everything, that we've kind of normalized that deviation across the part. Okay, so now I have in my tree, I've got an initial alignment and I have my best fit. So if I were to run my second part, the very first two things it's going to do is run the initial and then run the best fit, and then it's going to start extracting all of my features. All right, so first thing I like to do is do that 3D compare, and this part's pretty close, so, or I imagine it is. So when I do my 3D comparison, I can then see my color map here. So in the 3D compare, I can tell, if you've got an overall part profile tolerance of, let's say, 5 thousandths. Right now, it's set at a specific tolerance of about 4 thousandths. So I'm going to up that just a little bit more. So we'll say 5. Okay. So you can see my color map. Got a little bit less, but I've got some areas that are out a little bit. This is kind of a cheap plastic injection molded part, so I'm liable to have some deformation on some of these surfaces from the CAD file, which is fine. The max and minimum range you can set, I basically just use these. I usually end up setting about 10 times my specific tolerance, and that just controls how quickly or abruptly your deviation shades, transition between tolerance values. So what I can do here is maybe I want to show, especially on this initial part, well, maybe when I do a couple more parts, I'm expecting them to be kind of the same. So I want to know how far out some of this surface area is. I can come down here. I've got this local average tagging, basically what it is, these deviation flags. And I can click on areas that I may have some concern with moving forward. So you can see there, I'm going to actually change the orientation of those flags. There we go. All right, so here I've got a 12 thousandths tolerance deviation, about 8 thousandths, about 6 thousandths. I can add some more here, one there and one here. So maybe those are some of my areas of concern that I want to note that I can see are out, that I don't specifically have a dimension on, but in my overall profile, it's showing that those areas are out. So once I'm done with my 3D compare, I'm going to click my checkbox, say OK. All right, and there we go. So I don't need to see my comparison at this point. So I'm going to go ahead. Now you can see in my tree, this is basically broken down just like a model feature tree where all different function, your let's say planes and sketches and things like that are going to be grouped. And here it's the same thing. So I got my alignments, so I can actually collapse that because I don't need to see them. And then I got my analysis. So these are all my data, for my measured data. All right, so my 3D compare. Maybe moving forward, I don't need to see that for the moment, so I'm going to go ahead and hide it. All right, so next thing I'm going to do is run a cross section. So if I need to see, maybe I've got some sort of, let's see here. Anything, I can do a cross section angle between these faces here in 2D. I can go to my 2D compare, which is right next to 3D compare. All right, choose a base plane. So I can either choose one of my standard planes, or I can click on any of the planes on the CAD file, and I'll offset that up into the part a little bit. All right, so the 2D compare just basically lets me, and what would probably work even better is maybe maybe I've got a couple of profile planes across the top of the part. Either way, what this does is it gives me a 2D view that's essentially showing me kind of the same thing as my 3D compare, it's just in 2D. But all the options are the same. So I can adjust my tolerance span, so I can make this 5 thousandths. I can go in and do my localized picking. So if I've got some areas of concern, I can show that, okay, this part from my CAD file, that actual feature looks like it's shifted over, about 15 thousandths in one direction. So all this stuff we can call out. I'm going to go ahead and click my checkbox to exit that because it is just, it's a deviation color map. Okay. And now maybe I want to get to some of my deviations. So I've got, if I look at my measured data, all right, so there's my part. Maybe I want to see the distance between, this bottom plane here, maybe the bottom of the part, and this top face. What's nice is I can just click, I'll go to another one first. We'll do an angle dimension just to show you how this works. So I'm going to hide my mesh. I'm going to go to my dimension tab, and I'm going to use my smart dimension. I generally use that the most. And we're going to click on this face here. So we got a little plane. All right. And smart dimension basically gives us the dimension based on the feature that you grab. So it encompasses these 4 different dimension types. Now, if I were to click 2 angled faces and I drag that out, you can see there I've got my dimension. All right. So my reference dimension. And I can actually override that. So maybe the CAD model is a little goofy and I really need that to be 50, maybe as accordance to a CAD drawing. And my tolerance, 25 degrees, is definitely too large. So I'm going to put on a tolerance of 1 degree plus or minus. Okay, so now I can see that I'm looking for a deviation of 50 degrees plus or minus tolerance of 1 degree. And if I look at my table now, I can see what my actual measured value is 49.9433, so very close to 50. So that passes. All right, so to take dimensions, all I got to do is click on the face itself. I don't actually have to generate different features on the body if they already exist. Now, one thing I may want to do if I've got a dimension between this bottom face and this top face, what's pretty common is if you have a metrology table or some flat table that you're measuring from, which is pretty common in the metrology world. This face here isn't necessarily going to automatically recognize that it needs to pull measured data from this body out here. So what I can do is go to plane, and I can actually make a plane initially. So pick multiple points, and we'll just pick 4 points on this base. Okay. Check that, and now I've got a base. Now I got a plane there based off of that tabletop. And what I have is a pairing manager, which is pretty neat. So I'm going to go to pairing manager. All right, manual pair, and it's going to ask me for a reference entity, which is going to be that base plane, and then the measured entity, which is going to be that plane that I just assigned, or that I just assigned to that table. Click my checkbox, and then say OK. All right, so now those two are paired together. And what happens now is I can then take a thickness dimension. So I know that the part is flush with the bottom of this plane. So now I can go back to my dimensions tab and take a linear dimension between that face and this face, drag it out, and there's my model height there. Okay, with a tolerance, so I can make that, let's say, 5 thousandths. Okay. Here we go. So not only can we take just dimensions like this, but what I really like about the smart dimension, I'll do a couple more here and then we'll move on. But we got a smart dimension. If I click on a sphere, so let's take this sphere here. If I just click on the sphere and I drag this tab out, you can see it's giving me the diameter of the sphere. All right, and I can update my tolerances, whatever I need those to be. Thousandths. Okay. Now, if I want to get dimensions between spheres, you can also do that in the smart dimension. I can click on one, I can click on the other, and now because it's in smart dimension, it knows, okay, we're trying to take a dimension between the center points of those two. Now, not only can you take the center point, the dimension of the center point, but we can change that to maybe we need an overall dimension, a max dimension between the two. So I can change my first arc and my second arc to a max dimension or a minimum dimension, and now I got the outer dimension between the two. I can also change my alignment and make that dimension in the X or the Y axis, so I can see how wide those points are. Okay, so that's a few different functions there. We can also set surface profiles. This is totally updated GD&T, so we can set our surface profile here, and you see there that surface looks like it's going to fail. Okay, all right, and then we can do a positional tolerance. So if we decide we want to add, a datum, I don't necessarily have to have this sitting at in a datum alignment configuration, but I can do a datum A, and that's just as simple. I'm going to turn my mesh off, turn a couple of these dimensions off here. All right, there's datum A, maybe datum B, and let's make the center of this guy datum C. Okay, so if I need to do that, now I can change my position. I can add a position tolerance to this guy with respect to datum A, B, and C. All right, so we can do any of that sort of thing in here as well. Any dimensions there. All right, and once you're happy, once you've logged all your dimensions, you're good to go. We can go down here. What I really like is I can click on my GD&T group, and I can click on Apply Viewpoint, and I can see what my viewpoint looks like. Now that's really tiny. That's not going to show up all that well in my report. So what I can do is I can rotate this around to a view that I can kind of see everything I need to see. All right, maybe make that C there. There we go. There's my A, there's my B, that's my dimension. And then I can say, I'm going to click on group 1 and say reassign viewpoint. So now you can see my new viewpoint. That's going to be projected in my report. All right, so that's my 3D GD&T. 2D GD&T, I'll go through real quick again. We can go to 2D, and we're going to say add section. And I'm going to do it based off of this plane. And let's say maybe we drag it. Let's do drag it down on the part just a little bit. Here we go. All right. That way I get a couple of cross sections, or a couple cross section through these features down here. All right. So now when I click my checkbox, again, 2D GD&T works very similar. We can use a smart dimension here. Okay. There we go. I can actually add a point and change maybe I want to measure to the center of that slot. I can say find slot center. All right, and now I can do linear dimensions between the center of that slot and this part. So maybe I want to do an alignment for this hole here. So I want to do alignment in the X, and then do another one. Maybe we've got a tolerance call out to where we need an X and a Y. And now we've got a center to center. So even that dimension is very hard to do by hand because it's very hard to measure the center of that circle. All right, we can do overall dimensions if we'd like. If you've got a certain point within a part that you need to measure dimensions, so maybe offset planes every inch or something like that, we can go in and do a linear dimension because these are tapered. We can do linear or smart, doesn't matter, whichever one. And we can choose maybe that full offset there, or that distance. All right, and now we are all wrapped up with everything I want to do in a report. So very quickly, you can see I can generate features on the CAD file just by clicking on the CAD file. I can make constructed features, kind of like what I did with that spot point, and we now have a fully set up part. So if I want to generate my inspection report, generate report. All right, and just like last time, I'm going to change this to Neometrics template. I'm going to look in here and see what I don't need. So initial alignment isn't really useful to me. This plane I really don't need to see. Okay, and I think everything else is good to go there. So on a part you can, this isn't a timing cover, this would be sample part. So you can preset up your report headers. I can even add in a 3D PDF page. So if you need to see like a 3D PDF of the scan data, you can do that. Generally, I just show that on the alignment. So we'll say generate. While that's running, let me pull up my thing here. Is there a way to turn measured data? Sorry, I should have this up here. That's going to generate. So, so I got a question. Is there a way to turn your measured data into reference data? So yes, you can scan. You can compare scan data to scan data as well. So you can right click. I think we actually have to do it in input data. So let's see, add to result. Basically, what you do is you would import the data as an STL, and then you'd place it as a as reference data, and then you can then import scan data to that, and you know, compare scan data to that. You can set up you can preset up planes. So if you have a part that, let's say we have this part here. Before we go any further, I'm going to hide everything. But let's say you only have the scan data and you didn't have a reverse engineering software, but you needed to check it, you know, and you couldn't make the CAD file from the data. We can then go in and we can add things. We can add planes, cylinders, spheres, so we can add features to this and kind of drive those values as well. And that'll all be reference data, you know, that would be in the reference data column, and then you would just import your measured data and you would align to it. So some things you can't do, like surfaces and stuff like that. So this top surface would be a little tougher. The only way you would need to be able to measure that maybe is you do the cross sections and stuff like that, and that's fine. You can certainly get some really good data with that. But yeah, you can actually input geometric features to that scan. So generally when I'm running that, I'll do that in any sort of surface that I need to gather. I can actually run a 3D compare on those differences between them, and that's how we get those profile tolerances. Okay, so now that we've got our report ready to go, we've got, again, CAD data, scan data. All right, there's my alignment. So there's my best fit alignment. That's what you want to see in a best fit, that you've normalized the deviations across your part. All right, there's our color map deviation with our deviation flags. All right, cross section, our 2D cross section, and our 3D GD&T. So if I need to go back and adjust this, I can. If I want to place this above, you know, above the 2D GD&T, maybe I want it to come first, I can do that when I generate the report. There's all kinds of things you can do, but here we got all of our dimensions found within that field of view. So that's the quick rundown. And yeah, essentially when you're doing your import and you do it import as a reference data and pick an STL, it'll bump it into that reference column. Okay, minimize this here. All right, got another question. Can I use the smart dimension function on data without CAD? Yes, but you have to do kind of what I talked about a minute ago, is if I need to add, I'll run it here. So if let's just take all this stuff out of here and my group. There we go. So if you want to run a smart dimension, what you'd want to do is, you know, if I wanted to do like a dimension between two planes, I would use the plane that I have up here that I placed on my scan data. I could do another one. You know, let's say, let's just run it with the paint. So I'll paint that, make my plane. All right, so if it's not totally parallel, you can again go in, do dimensions, 3D GD&T, and do a linear dimension between those two. Now it may come back and tell you, you know, these aren't parallel, but you can type in whatever that value needs to be and override it, because they're so close to parallel. It's gonna pull it anyways. But that's how you would run that smart dimension there. All right, and then that just disappeared because I have the 3D groups turned off. Here we go. So, you know, same thing with the sphere. If I need to add a sphere, I can do that similar function. So we'll go to sphere. All right, I'll paint. Let's see if I can get away with just painting just that a little bit. Okay, so you'll add these features to your nominal scan. There we go. And then once you import your reference, or sorry, once you import your measured scan, you know, the scan of the new part that you need to measure to, it's going to automatically pull that sphere. So it recognizes that sphere is in that place on that scan data, and it'll pull the measured value when you import it. So that's, and then from there you can do the same thing. You know, if you need to see, say smart dimension, you want that projected in your report, you can choose it. If you need to see a dimension between the, let's say the max height of that sphere and that plane, we can do that as well. All right, and that's how you would run it. I just don't have it set up in this one yet to do it, but that's how you would that's how you'd apply that. Okay, let's pop this back up here. Go back to my webinar. All right. Is there any other questions? That's the workflow. I want to show you guys for setting everything up. At the end of the day, here we can do our PDF, export it as, say, sample inspection. All right, save. And now we're ready to move to the next part. So at this point, we can minimize this one. Let it save out for just a moment. Okay, minimize that. Let's minimize that view. All right, and what I would do is, you got a couple of options, but I usually just do duplicate result or add result and copy it from result data 1. Essentially, that puts a second result data in your tree. And then from here, you go to my home tab, and you can either delete this data out and re-import data, but I generally find the replace measured data works great. All right. Run inspection process. So then your scan data 2 would then come up. There we go. Your scan data 2 would import, and it would run that same inspection, and you would have result data 2 at that point, which would be your second part. All right. This is going to give us the same values, obviously, because this is the same scan. But if I were to go scan a second part, it would pull new ones. So yeah, that's the end of my workflow here. Again, anybody have any questions about Geomagic Control X Essentials package specifically, or just the Geomagic in general? I'll give you guys just a couple minutes for questions, and then we can wrap up for the day. All right. Is there a way to get a copy of the PowerPoint? Yes. So this whole thing, we're actually going to make this live, or we're going to send it out. So the recording of this will be available shortly. All right. Other than that, I think that's it, unless I see something else come through. Again, I'm going to put my contact info back up here. All right. So yeah, my name is Kenny Hart. I'm a sales engineer with Neometrics Technologies. So if you got any needs for this kind of thing for inspection, maybe you need to, you got some parts you need to solve, or your CMM is kind of overwhelmed, especially with parts that don't need 1/10,000th of an inch tolerance, type stuff. It's really kind of a waste to bog your CMM down with parts like that. So that's where 3D scanning really works extremely well, because we can do, our scanner is accurate again to 25 microns, or just under, about 9/10 of a thousand. We can scan very quickly. We can take that burden off of the CMM, and we can scan a lot of parts that a CMM can't even measure. So we do that as a service. We offer one-off type stuff as services. Most people with the inspection workflow are going to actually look at getting the software because they have ongoing inspection needs. All right, is there any tool to measure the surface roughness? I don't believe it's, so the Essentials package, there is some deviation tools in the main Control X function, but in the Essentials package, those are actually removed. So I've got everything in here. I want to go over a lot of the tools that are accessible in the Essentials package, but essentially they just have a few things either grayed out or gone from this software. We do have some functions, so to go along with the 3D compare, if I hover over this, virtual edge, so if you need to see the edge of a radius, we can measure that. Let's see here, we've got silhouette deviation, plot, so deviation plot, stuff like that for thicknesses. But under tool, or sorry, under, where are we at here? Under the comparison tab, yeah, we've got some deviation locations, so you can actually measure dings and dents and things like that, and protrusions. But that's actually not a function. That's a function of the main software, not of Control X Essentials. There we go. All right. Looks like that's the last question that's come through. If you have any follow-up questions, feel free to email me. Again, Kenny@neometricstech.com, and I can answer any of those. You can either call, that's my number, or if you dial the main line, 888-696-7226 is actually Neometrics' main line. And from there, you can access sales, engineering, technical support, anything you need. All right. Well, I'm going to wrap that up. Let me go ahead and turn my screen share off. Thank you, everyone, for joining me here, and I hope to hear from you. Again, we'll follow up with everybody after this with the link for the actual webinar, so you can go back and watch it or share it with anybody you need to at your work. But again, thank you, and have a good rest of your what is today, Tuesday, and we'll talk to you soon.